All right, this video is for Chapter 5. This problem is on the class problems section 5.1. So if you actually are using those or looking at those, this Excel file kind of supports that problem, actually problem number 3. So it's a basketball free thrower, right? And so I've calculated all the probabilities based off what we've learned in Chapter 4. In Chapter 5, most of the time your PDF, your probability distribution function, will be built for you. So just like the rule said, for a probability distribution, you have to have some event, whole values, because it's discrete. I have to have a probability that corresponds to each event, and the probabilities have to sum to 1, which they do. All right, so if they don't sum to 1, then it is not a probability distribution function. Make sure you check that, because there will be some homework problems that you'll go through the whole process, and it will not work. So I'm going to build a couple things in here first. So this column A and B is called my probability distribution function. This is the probability that x, that probably some random variable x equals some event, little x, right? So if I want to find the probability that some random x equals that the basketball player makes exactly 2 shots, well, that is just the value in the table of 0.441. So that's why a probability distribution function does for us. It gives us the value right out of the table for when it's exactly or equals. If you want the probability that you make at least 2 shots, so that would be less than and equal to, so I'm going to put a little equal in here. I don't need to equal no more, to 2. That is called our CDF, our cumulative distribution function. So 2 ways to do that. I can either add up making 0 shots, because that's less than 2, plus making 1 shot, because that's less than 2, and making 2 shots, because that is less than or equal to 2. And the probability that I make at least 2 shots, at most 2 shots, not at least. At least is the other way. At most 2 shots is that. If I wanted at least, then I'd do the complement. So 65% chance that I'd make 0, 1, or 2 shots. Or you can build a CDF, which we annotate with a capital F. So build a CDF, a cumulative distribution function. I start off with my first value. So probability that x equals 0 and the probability that x is less than or equal to 0 is the same. Now, the reason it's called a cumulative, and we talked about this back in histograms chapter, so if you go back and read, I think it's in section 2.2 or 2.3, it'll talk a little bit about a cumulative function. But cumulative means add. So all I'm going to do is take my previous cumulative value and add it to my next probability distribution value. Right? And if I keep doing that, my previous cumulative value added with my next probability value, and then lastly, my previous added to my probability, and you see I end at 1. And you will always end at 1. So, like I said in the blog from week 5, chapter 5, you can display as a table, which I have here. I can also display it as a graph. So if I want to display it as a graph, I highlight my x and p of x, and I insert. Oh no, I want to go to charts. Not a line. I want a scatter. Where are you at, scatter? Sometimes my Mac is not. Yours is much easier to find because I actually I just have to go to other, I guess. There we go, scatter. On the PC, it's a little bit easier. Why didn't you give me what I wanted? Delete. Insert scatter. There we go. So there is my chart of my P of X. And then, so I like to add lines. So I can actually pick up my lines here. I've already created them. Again, this is much easier to do on paper than it is in Excel, but so he's right there at 1. He's right there at 2. And he's right there at 3. Now it's behind my graph. So send to the back. There they are. Now, if I wanted to do my CDF, if I want to graph my CDF, I just equals my previous values. Because you got to have your columns next to each other. If you do not, it's not going to work. So now, again, same thing. I can highlight, insert a scatter, and there is my CDF. So there is my first line, my second line, my last line is short, and my third line. And basically a CDF, so again, send it to the back. My lines are behind my graph. Send to back. Looks like kind of like stairs. So I'm at this. I get that line's a little too long now, so let me shrink him down a bit. And I step up, walk, step. So CDF kind of looks. So those are my two graphs. All right. Now, what if I wanted to find? Sorry, one last thing. So I can either add these all up as a PDF, or if I create a CDF, it is just the value where it equals 2. I mean, you see, you get the exact same answer. So CDFs are not really used much anymore because we have technology. They were used a lot when we didn't have technology. To find expected value, the formula says I take my x and I multiply it by my p of x. So as you can see, I take 0 and times it by 0.27, which is 0. Well, if I drag this down like we've learned before, it does the same thing. So there is 1 times 0.189, 2 times 0.441, and then 3 times 0.4343. And if I add them together, I have a mean. So I expect to make 2.1 shots. You do not round the mean. All right, I know it doesn't make a lot of sense, but if you round it, it messes up your calculations in the future statistical analysis. So you can round it due to significant edges if it goes on forever, but do not say my mean is 2. My mean is 2.1. All right. So to find variance, you take your x value, you subtract it from your mean, you square it, and then you multiply it by your probability. And you do that for every single event, or x value, and then you add them all up. So notice in here I put dollar signs in because my mean doesn't change. The only thing that changes is my x and then my probability of x. So I go to the next one. It's 1 times 0.189, but I'm still subtracting the mean of 2.1 and I'm squaring it. Remember, this little caret sign makes it as an exponent. If you prefer the shortcut formula says I square my x and then multiply it by my probability. And I do that for all of these. And then I add those up, and then to find my variance, I take that sum, I minus the mean squared, and you see I get the exact same answer. If you want to find standard deviation is just the square root, SQRT, of the variance. Why is that a plus sign? Why didn't that work? SQRT of this. There we go. So my standard deviation is 0.79. My variance is 0.763. Remember, variance tells me how spread my data is, right? And you can kind of see this in our graphs from the mean, right? So 2.1 is right here. And so that's 0.63, 1 standard deviation away, 2 standard deviation. I'm sorry. The variance is the variability. Standard deviation is how far away. So the range rule of thumb, right, which we learned. So if I want to find my lower and upper, based on the range rule of thumb says I take my mean and I subtract 2 standard deviations. So my lower limit is 0.89, if I'm 2 away, which is just below 1. And my upper would be my mean plus 2 times my standard deviation, which is just under 4, right? Which is above the scope because we're only taking 3 shots, so I can't even get there. No, I put plus, not times. That's probably why it didn't give me the right, why it didn't look right. There we go, 0.51. So between here and here is all my data. And you can see in the discrete world it kind of messes up a little bit, but that is how you use the range rule of thumb. The reason I say mess up in the discrete world is because our baskets are 0, 1, 2, and 3, so we're between these two things. Alright, so, and all of that again is kind of written now in class problem section 5.2 question 3, but this is how you use Excel, and this is all kind of 5.1. 5.1 is verifying that you have a probability distribution function by summing to 1, that you have some events that are whole numbers, and you have probabilities that correspond to each one of those. That's a probability distribution function. Then I can use it to answer questions about exactly, comes out of the probability distribution function, less than or more than, I just have to add these up or create a CDF. To find expected value, I just use the formula that's in the blog or the book, and I use Excel to do my calculations. Same with variance and same with standard deviation. All right, and this Excel file is uploaded as chapter 5 if you want to kind of pull it down. All right, if you want to do a binomial, all right, this is all pre-built again. So this is the sum of dice rolls, right? So one roll of a dice can be 1 through 6. One roll of a dice can be 1 through 6. Here is all my possible outcomes. Again, back to chapter 4. Remember, a binomial has to be success or failure, right? So rolling a dice is not binomial, but if I classify my event as a sum of 7, which means that everywhere that these things equal 7 is a success, and then my failure, right, and I'm rolling it 10 times, my failures are all the other numbers that are not 7s, right? So I'll highlight these so you can kind of see what I'm talking about. So that, wherever I'm putting is considered a success. So this is binomial because I have a success or failure. I either get a 7 or I do not. My trials are 10. I'm rolling the dice 10 times. The probability of success is 1, 2, 3, 4, 5, 6 out of the 36 different ways you can do it. And now I created a table, a probability distribution function. So there is my 0 through 10 rolls. There is the probability of getting 0 7s all the way up to 10 7s. Remember, E is scientific notation, right? So in this one right here, I got to move the decimal place 8 spaces this way, so there's 7 zeros in front of this. So that's basically saying almost a 0% chance that I will roll a 7 10 times in a row. It's not exactly 0, because there is a chance, it's just very rare. All right, and then you can see I created my CDF here. So, and why it's good to learn the CDF is this. In Excel, for the known distributions like binomial, there is a thing called binomial dist. Right? So I'll do it down here so you don't have to see my table. So say we wanted to know the probability that I get exactly 5 7s in 10 rolls. Okay? Well, I've already built the table so you can pull it out of it, but if you don't want to build a table, you just type in your Excel equals binomial dist, right there. First, it needs the number of success. Well, my number of success is what my x equals, so that is 5. Then it needs my trials. Well, I'm rolling the dice 10 times, so there's my 10. Then it needs to know, oops, I hit 5 instead of comma. Now it needs to know my probability of success. Well, that is right there. And then it wants to know, do you want the CDF or not? If you want the CDF, you put in the value 1. If you want the PDF, you put in the value of 0. And since I'm doing equals, I put in the value of 0. And there is the probability that I get exactly 5 7s in 10 rolls, which you can see matches my table because I built it that way. If I want to know the probability that I get at most 5, right? Sorry, I went the wrong way. At most 5 is less than. And this is the hard part with chapters 4 and 5. It's the wording. You've got to be really careful with the wording. So the probability at most 5, well, it's the same thing, binomial dist. My number of success, again, is still 5. My trials are still 10. My probability of success is still the same. But now because it's less than, I want the CDF. So there is a 0.997 or 99.8% chance that I get between 0 and 5 7s in 10 rolls. Now this is where you have to be careful in the discrete. What if I want at least 5? Well, that is equal to what? The probability that x is greater than or equal to 5. Put my little equals in there. Right? Well, CDFs only do less than. So the only way to do this is to do the complement rule. So this is why we had to learn the complement. So the complement of at least 5 is 1 minus less than 5, right? Or, since we're discrete, 4 or fewer, right? So then I just do binomial dist. And why am I not getting my thing here? Why are you being stupid? Equals binomial. There we go. I like to bring it up because just to make sure Excel knows what I'm talking about. Now I'll go back and you put my 1 minus since I didn't like it. I mean, I'm pretty sure it's just because I have an older version of Excel and Mac on here. So I put in 4, get the parentheses, 4, comma, 10, comma, I've got my comma, 10, comma, why am I, comma, 1. And there is the probability of at least 4. I'm sorry, at least 5. Sorry. All right, going to continue on now with some of the video into some of the homeworks. So here's how I would do section 5.1. So here is our probability distribution function. So then I can open it in Excel. Make it a little bit smaller because I don't need that big of Excel. I'll bring it over here. I'll make this guy a little bit smaller so we can see both. Right. First, I want to know, is it a probability distribution function? The easiest way again is, well, I made it too small, so I lost my auto sum key. Auto sum, it sums to 1. So it is, yes, the table shows a probability distribution function. Then it says I want to find the mean. Well, to find the mean, remember it was equals this, your x times your p of x, and then you drag it down, because that does them all, then auto sum that guy, 2.5. Find standard deviation. First, you need to find the variance, and then take the square root, and you'll find the standard deviation. I'll let you guys kind of play with that one. Go back to the beginning of the video if you want to see how to set up the variance formula. All right. I don't mind doing it. We'll do it real quick. So this was e of x. This is v of x. Now, so to find the variance, it is parentheses x minus the mean quantity squared. Remember, the mean doesn't change, the x's will, so I'm going to put dollar signs in front of my mean. That locks it so it doesn't change. And then I have to times that by my probability of x. So there's my first v of x, bring it all down. And then I auto sum it. There's my variance. And then to find standard deviation, we take the square root of this 1.12. So it wants one decimal place, so 1.1. The only time you're going to hit the other answer is if you say it's not a probability distribution in the end. So that's how you can quickly do 5.1, playing around with the formulas. If you get good with Excel, it helps. If you want to do them by hand, you can. Excel is not required, but that's why I'm showing you how to use it to kind of help. So I'm going to get rid of Excel. And see, here's another one. So it's just doing those a few times. We've talked. Well, that's not what I wanted to happen. Okay. So 5.2 is binomial. So the video on binomial shows you how to do those. And then 5.3 is Poisson. So let's see if we can find a Poisson problem here. So in the handout, I explain what a Poisson is. The Poisson distribution is expected number of arrivals in a given time period, or expected number of outcomes, or whatever. Typically, it's I'm sorry, in an interval. Typically, it's a time period. So 7.7 per year. So I should have kept Excel open because I'm going to use Excel to do Poisson. So assuming Poisson distribution implies that the mean number of hurricanes in a certain year is 7.7 per year. So we get our rate is 7.7 hurricanes per year. So hurricanes per year, right? So find the probability that in a year there will be 6 hurricanes. So the Poisson, again, because it is still in a year, my mu, or my mean, or expected value, equals the 7.7 since this problem is in years, right? So to find the probability there will be 6 hurricanes, I'm assuming they want equals. Sometimes the homework can get kind of tricky with their wording. Well, not clear, not tricky, kind of not clear, but say will be 6, I'm assuming equals 6. So probability is Poisson. There's the Poisson dist. You need your x, which is in there. That's why I always write mine out with equals or less than or equal to, because it reminds me what I'm doing. There's my x, there's my mean, and because it's equals, I don't want the CDF, so I put in 0, and I get 0.131. The expected number of years with 6 hurricanes is, oh, in a 35-year period, how many years are expected to have 6 hurricanes? I don't quite understand this question. Oh, they want you to find a new, okay, it's the rates change. This was per year. This is in 35 years. So if I have 7.7 hurricanes per year, how many do I expect in a 35-year period? Well, I'll multiply those two numbers together. So equals 7.7 times the 35 years. So we expect 269.5 hurricanes in 35 years. Oh. All right. So they say multiply the probability. I thought they wanted a new mean. So let's do it their way then. They say take 35 and times it by our probability. Oh, that makes more sense. They didn't want, I answered the wrong question. They want to know how many years do we expect to have exactly 6 hurricanes. It is 4.6 years in a 35-year period. There we go. What I found originally, this is my new rate, right? Because if we have 7.7 in a 35-year period, we expect a total of 269. So this is total. This is how many years have exactly 6 hurricanes based on our probability. So there's how you do the calculations for a Poisson, right? So let's see if we can find another one. I'll let you play with the theories here. Make sure you got a good understanding of them. That's not what I wanted to do. I want to go to the next question. I'll leave. I want to see if I can find a CDF one. Now this is one just going through and finding all the values of Poisson. I'll let you work that one. I might not have given you a CDF one. And that's just the rules. And again, there's the rules. So let's go back to question 1, because I think I started 2. Let's see if 1 is anything. Oh, this is just finding the 3 values here. Alright, so I think I've given you enough. You can kind of play around with these things. Make sure you kind of read. There's not a lot of reading to these chapters. Because once you get 5.1, all 5.2 is the binomial, which follows the same rules of 5.1, but it's binomial specific, which means you just do binomial dist in Excel. And 5.3 is just Poisson dist specific, so you just do Poisson dist. Again, x, then your mean, and then 0 if it's equals, or 1 if it's less than or equal to. All right, again, reach out to me if you have any questions or concerns, and I will get back to you as soon as I can. Have a good week.